In this video, we're going to talk about back titration. So back titration involves you reacting an acid which is in excess with a substance of a known concentration. And in another reaction, you're supposed to react the acid that was in excess with a base of known concentration. Okay, so let me use what I've written down to help you understand. So let's say B is an acid. We know the concentration of B. Yet, we are trying to determine the concentration of A because we don't know its concentration. So, our acid is going to be in excess, meaning that it is not going to be depleted in the first reaction. So, as we proceed to the second reaction, the same acid that has remained will be reacted again with a base of known concentration. For example, you can react HCl with sodium hydroxide. So from there, after determining how much of the base has been used up, you can be able to determine the number of moles that are reacted with the HCl or the acid. So after determining the number of moles that reacted with the acid, you're supposed to now determine the volume of the acid that reacted in the second reaction. And after determining the volume of the acid in the second reaction, you'll be able to subtract now from the initial volume of the acid in the first reaction. The difference is going to give you the volume of the acid that reacted in the first reaction, and that will help you determine its number of moles and relate it with A for you to determine the number of moles. So for us to understand that better, let's get to do an example question. So given that the mass of magnesium hydroxide in an indigestion tablet was determined as follows. Step 1. The tablet was crushed and dissolved in exactly 40 cubic centimeters of 0.5 molar hydrochloric acid. So that is the equation that is showing you the reaction. Then in the second reaction, the amount of hydrochloric acid remaining was again measured by titration with 0.250 molar decimeter cubic sodium hydroxide of that. So then 22.8 of this sodium hydroxide was required. Calculate the mass of magnesium hydroxide in the tablet. Okay, so it's called back titration because we start from the second reaction. So in this case, let's start with the second reaction and write the chemical equation. So we have hydrochloric acid. Let me use a different color. Okay, so we have hydrochloric acid reacting with what? Reacting with sodium hydroxide to give us what? So this is a neutralization reaction, so we will have sodium chloride with what? With water. So now if you look at this question, what information have we been given? So for HCl initially, from the first statement that we've been given its concentration to be 0.5. So this HCl is its concentration is 0.5 molar concentration. Then now what is the concentration of sodium hydroxide? So it was 0.25 molar. So the concentration of sodium hydroxide is 0.25 molar. What else have we been taught? So these are the concentrations. So we've been told that a volume of 22.8 of sodium hydroxide was required. So we have got a volume of 22.8 cubic centimeters. So we know that molar concentration is the same as mole per decimeter cubed. So we need to work with the same volume and the same what? The reaction. So let's use the same units. So we need to convert the centimeter cube that we've been given as a concentration, as a volume of sodium hydroxide. We need to convert it to decimeter cubed, and we do that by dividing by 1000. So 22.8 divided by 1000 is going to give us 0. So this will give us 0.0228. So that becomes our volume in decimeter cubed. Okay, so this is the volume of what? That is now a volume of a sodium hydroxide that reacted. Okay. So now that we have the volume there, we are able to determine the number of moles. So how do you get to determine the number of moles? So we determine the number of moles by multiplying the concentration with what? So if we multiply the concentration with the volume of a sodium hydroxide, so 0.25, so we know that molar concentration is the same as mole per decimeter cubed. Okay, so that's what we have. So these the units will cancel out there, then you remain with a number of moles. Okay, so 0.0228 multiplied by 0.25, you have, so we have a number of moles now. The number of moles are 5.7 by 10 to the power negative 3. So these are the number of moles of sodium hydroxide that reacted in the second reaction. So we are interested in determining the number of moles of what? The number of moles of HCl that reacted. How do you go about it? So you look at the equation that you've come up with. Look at the mole ratios. So this is 1 to 1, meaning that the number of moles of HCl that reacted in this reaction should also be equal to the number of sodium hydroxide moles. So from the number of moles of sodium hydroxide that we've determined, it is also going to be equivalent to the number of moles of what? Of HCl, because they're in the ratio of 1 to 1. In a case where they're in a certain ratio, you're supposed to say 1, for example, if it's 1 to 2, you say 1 to 2, then come up with a ratio, a relationship, and be able to determine the value of the number of moles for the other reactant. Okay, so now we have the number of moles of HCl and its concentration. We can now determine the volume that reacted in the second reaction, because that is our interest. After determining the concentration in this second reaction, we'll go back to the first reaction, because in the first reaction we were given the volume of what? The HCl. So what we are going to determine in the second reaction is going to be subtracted from the first reaction, so that now we determine how much had reacted in the first reaction. So let's try to move. So we know that concentration is actually given by number of moles dissolved in a given what? Volume. Okay, so we have the number of moles here, and we have concentration. So if you make volume to be a subject, it becomes volume is actually going to be given by the number of moles divided by what? Divided by the concentration. So number of moles divided by the concentration. Okay, so we have our number of moles there, we divide it by the concentration, so we are multiplying. So we have 5.7 there, remember. So we are dividing by what? The 0.5 molar. So molar is mole per decimeter cubed, so we'll say decimeter cubed over 0.5 moles. Okay, so the moles will cancel out, then you remain with decimeter cubed. So 5.7 by 10 to the power negative 3 divided by 0.5, we have 0.00, okay, sorry, it's 0.0114 decimeter cubed. So this is our volume of HCl that reacted in the second what? In the second reaction. Okay, so we're interested in determining now the volume of HCl that reacted in the first reaction. So how do you go about it? We'll now subtract. So for us to subtract, we need to make sure that the units that we're working with are matching up. So if you look at the first part, so it's called back titration. We've done the second experiment. Let's go back to the first experiment now. So in the first experiment, we are given that we add 40 cubic centimeters of HCl. So we need to convert this to decimeter cubed so that we are able to subtract. So we divide by 1,000, because 1 decimeter cubed is equal to 1,000 cubic centimeters. So 40 divided by 1,000, we have 0.04. So 0.04 decimeter cubed. This is what we had initially at the start of the experiment. Okay, so knowing that all of the remaining part that reacted in the second experiment has been determined, we can subtract now to determine what reacted in the first reaction. So let's try to subtract This part is coming from the second reaction. So let's subtract it from what we started with to determine what reacted in the first experiment. So 0.04 minus 0.0114. Our difference is going to be 0.0286 decimeter what? Cubed. So this is the volume that reacted in the first experiment. Okay. So what do we do now that we've determined the volume? And if you look at the first part of the experiment, you are also given the concentration of the acid that you're using. So you are also able to determine what? The number of moles. So number of moles, we understand that it's a product of concentration by volume. Remember the formula that you are working with is this one. Concentration is equal to number of moles over volume. So if you make the number of moles to be the subject, you come up with this part now. Okay, so we have number of moles being equal to, we've determined, okay, the concentration was already given is 0.5. So we have 0.5, of course, moles per decimeter cubed. We are multiplying this with the concentration that we've determined to be 0.0286. Okay, decimeter, so 6 decimeter cubed. So the decimeter cubed will cancel out. So you have 0.5 multiplied by 0.0286. So we have now have 8.11, oh sorry, it's 8.1796 by 10 to the power negative 4. So this is these are the number of moles of HCl that reacted in the first reaction. Okay. Okay, so let me just try to punch that again. We have 0.0286 multiplied by 0.5. So apologies, that wasn't supposed to be the answer. I punched that twice. So it's supposed to be 0.0143. These are the number of moles that reacted in the first reaction. That is for HCl. So if you go back to our reaction there, this is our equation has already been given in the first part. So we've determined the number of moles of HCl, and the ratio there is given to be 1 to 2, as we can see. So we have our magnesium hydroxide. So magnesium hydroxide, okay, we're comparing it with the HCl. Okay, so magnesium hydroxide is 1, for HCl it's 2 as a coefficient there. The coefficient is 2. So we have a number of moles for HCl to be 0.0143. So we're trying to find the value of X on the other side. How do you go about it? So you cross and multiply there. So you have, for you to find the value of X, it's going to be 0.0143 divided by what? You divide by 2. So if you divide that by 2, you have 7.15. 7.15 by 10 to the power negative 3. So now what you've determined are the number of moles of magnesium hydroxide that did what? That reacted. Now what is the question asking us to find? The question is asking us to determine the mass of magnesium hydroxide in the tablet. So we've determined the number of moles. We want to find the mass. So if you go back to the first relationship of the mass and the number of moles, you find that the number of moles is actually also determined by the mass divided by the molar mass. So for you to find the mass, it's supposed to be a product of the number of moles by what? By the molar mass. Okay. So we have a number of moles there. We need to determine the molar mass of magnesium hydroxide. How do you do that? So magnesium hydroxide you go to your periodic table, come up with the molar mass. I believe we all know how to do that. So if you check magnesium, it is approximately 24. So approximately 24. So you plus, of course, we have a 2 there. Then oxide there, we have approximately 16 for hydrogen. For hydrogen is 1.008, for oxygen it's 16 approximately. So you have 16 plus 1.008 in the brackets, multiplied by 2 plus 24. So approximately you have 58. Okay, so therefore we have the number of moles to be 7.15. So the molar mass is approximately found, determined to be 58.016. Okay. So our mass is going to be, let me just create some space down here. So our mass therefore is going to be determined by the product. So after doing your calculations there, you find that the mass is going to be 0.415 grams. Okay, so that's it about back titration. I just hope this video gave you an idea on how to go about it. What is important is for you to know that start from a second reaction, determine the amount of acid that reacted in the second reaction, then subtract from the initial in the first reaction. Then you'll be able to determine how much had reacted in the first reaction. From there, use the mole ratios to relate it with the substance of unknown concentration. Okay, sometimes they may ask you to determine the volume of the substance of unknown concentration that reacted. Okay, so that's it for this video. Thank you very much for watching.